Hello. So the purpose of this video is to help you review the levels of measurement because they become very important as you move through statistics to help you determine what statistical analysis are most appropriate given the variables that you have. So levels of measurement are denoted for every single variable. A variable we know is mutually exclusive, exhaustive, and operationally defined, but then it's further classified as a level of measurement. Level of measurement starts with nominal, but it then goes up in a hierarchical range up to ratio, where ratio is considered the highest level of measurement. So as we go in this lecture, we're going to introduce the concept of nominal variables, ordinal variables, interval variables, and ratio. And in each of those levels, we're going to add one extra component that makes the variable a little bit more complex. The lowest level of measurement is nominal variables. They are exhaustive, they are operationally defined, but one of the key identifying characteristics is that they are mutually exclusive. They basically separate people into groups or categories without any sort of ranking. So things like gender, whether you're male or female, would be a nominal variable. You could also look at division 1, 2, and 3 sports. Division would be your nominal variable. You could look at sport type. So if a person was a basketball player, or if they played soccer, and I think my soccer ball might be not quite so impressive, but any of these would be the types of things that would make up nominal variables. Now notice there's no rankings here, there's no inherent system. It's you are one or the other. You could also have history of injury. So it could be something along the lines of ACL tear or no tear. You could have experimental and control groups. And in those situations, you all have nominal variables. The second level of measurement now adds a ranking. So for the first time, instead of just being even groups, we now have somebody is higher than somebody else is higher than somebody else. The example that I give in class is finishing off a race. Who got first place, second place, and third place, and so on. We know that there is a ranking. Clearly somebody did better than other people, but the distance between the first place and second place finisher might only be 0.3 of a second, where the distance between the second and third place finisher might be 2 minutes, and the distance between the third place finisher and the fourth place finisher might be 35 seconds. So there's no standardized scale. The distance between 1 and 2 is not the same as the distance between 2 and 3 or 3 and 4. So other examples is sometimes we ask people, how much pain do you feel? Where 0 is absolutely no pain, I'm very happy, and 10 is the worst pain you've ever felt. So in this case, your 0 and my 0 might be similar, but if my 0 is from the pain that I experienced when I broke my collarbone, your 0 might be the pain you experienced if you were in a car accident ever, or your pain might not ever be that bad. You could have a very low pain threshold because the worst injury you ever had was turning your ankle. So because we have different ways of defining what pain is, we're going to have no standardized scale. The other very common type of ordinal variable is a Likert item. So you're probably used to seeing something like this, where you have strongly agree, neutral, disagree, and strongly disagree as your options, and these are usually related to 1, 2, 3, 4, 5. Well, if I were to ask you the questions, to what extent do you like statistics? Well, you might have had some good experiences with statistics before, and you might put that you strongly agree that you like statistics. However, if you compare your strongly agree, where, hey, I like statistics, it doesn't make me want to cry, and my strongly agree, where I decide to live and work in statistics for the rest of my life, then we have very different opinions for what strongly agree is. So as a result, the difference between a 1 and a 2, or agree and strongly disagree, or how we define these variables, is very different, and we can't say that there's a standardized scale. So basically what that's saying is if we were to answer a 1.3, that would make absolutely no sense. It would not be meaningful data, because really the only numbers that make sense in this is a 1, a 2, a 3, a 4, and a 5. So if you have one Likert item, then you have an ordinal variable. So with a interval level of measurement, which is the next level up, we have a ranked variable. So we still have 1, 2, 3, 4, but now we have what we call a standardized scale. That means the difference between 1, 2, and 3 are all equal. The difference between 1 and 2 is the same as the difference between 3 and 4. But we have this additional term called an absolute zero, and we need to define what the heck absolute zero means. An absolute zero means a true zero. True zero. That means that if you scored a 0 on the variable, nothing exists. Nothing exists. But we know that in some situations you can have a 0 and still have the variable. For instance, when we look at temperature, we know that 32 degrees is freezing, 0 is really cold. But that 0 does not mean the absence of temperature. It means it's really, really cold out. So as a result, there is no absolute 0, and temperature is an interval level of measurement. Other examples, if you have golf, where with golf handicap, you can get a different handicaps of +1, +1, +2. You could have a scratch, which is essentially a 0 or a little bit below a 0. So the 0 point isn't meaningful. It doesn't mean that you can't hit the golf ball. What it means is that you tend to score on par. This is also the case if you take a whole bunch of Likert items and you average or sum them. So an average we're going to write by using the X bar or a sum. We're going to use sigma, Greek letter sigma. If you take the average or the sum of maybe 5 Likert items that are all asking about how much satisfaction you have taking statistics courses, then all of a sudden the difference between 1, 2, and 3, and 4, and 5, that strongly agree, agree, and disagree, that 1.3 that we talked about before becomes meaningful because we've defined the distance between 1 and 2 through the average as being 1.3 is now closer to a strongly agree than it is an agree. So all of a sudden, if we have 5 Likert items, or really anything more than 1 Likert item, we have an interval variable. But notice I don't have a 0 on that scale, a 1 to 5. And if I don't have a 0 point, I can't have a ratio variable. So this is still an interval level of measurement. Now, the last one we're going to finish off with is a ratio level of measurement. A ratio level of measurement is ranked, has a standardized scale, and has an absolute 0. This is the one that you're probably the most comfortable with because it's the one that we all have the most experience with. You could have 10 kilogram weight. That is going to have an absolute 0 because if we had a weight that had 0 kilograms, the weight wouldn't exist. So weight has to be a ratio level of measurement. If you were, kind of sticking with the weight, going to bench press a whole bunch of weight, that would also be a 1 RM bench press with kilograms is going to be a ratio level of measurement. Batting average is going to be a ratio level of measurement because when you take the average, if you have a 0%, means you didn't hit any of the balls that were pitched to you. Also, anything that measures in years, seconds, minutes. So distance, weight, kilometers, or distance, weight, time, these are all ratio levels of measurement. So we're going to check or stop off with a little check for understanding, see what you know about this. So I'm going to ask you if each of these is what level of measurement. You can pause in between and think about it, and then I'm going to write the answer in. So the first question is the average score on the Tennessee Self-Concept Scale, which is a 10-item questionnaire. You fill out all the questionnaires about your self-concept, and then you get an average score. So what level of measurement is that variable? You could also do a 1 to 10 or 0 to 1 to 10 scale on how approachable is your professor, 1 being not approachable at all, 10 being extremely approachable. You could ask somebody what their birth weight was. Or you could ask somebody what their political affiliation is. So maybe you're a Democrat, maybe you're a Republican, maybe you're independent, maybe you're not affiliated. So take a second, pause the video, and then come back in when you have an answer. So the answer for the Tennessee Self-Concept Scale is interval, and the reason is because it's got those 10 items, and when we average Likert scales, we're going to have a interval level of measurement because there's no absolute zero, there's no true 0 point, but we still know the difference between a 1, a 2, a 3, and a 4. For number 2, on a 1 to 10 scale, how approachable is your professor? Well, your definition of a 10 might be very different from another person's definition, but we still have a ranking. A 10 is better than a 9 is better than an 8. So that's going to make this one an ordinal level of measurement. Birth weight is measured in pounds, it's measured in kilograms. If the baby is 0 pounds, then the baby doesn't actually exist. So as a consequence, then this is going to be a ratio level of measurement. And then finally, political affiliation, depending on where you fall on the political spectrum, being either Democrat, Republican, independent, or nothing, or no affiliation, these are all just groups, but there's no ranking or inherent order to them, so this is going to be a nominal level of measurement. I hope you found this video helpful, and thank you.